Okay, so this is the first day of working on developing the Rover Robot, and because I already have a working robot platform that I've used for another artwork, and I'm confident with how to control that and make it drive around, I'm concentrating at the moment on controlling the robot arm. So the robot arm will have a webcam attached to it. It's this one here. It's got the webcam attached to it at the top, and I just want to start developing a control system for the robot arm and also the hardware for making it run on the robot platform itself. So it's just one of these. Bought it on eBay. The one that I bought came with servo, so I didn't have to source the servo separately. It was about $80 or $90, I think, and it looks a bit like this. It's this one here. So what I've got for the robot arm is, because it's 6 servos and that would take up a fair amount of ports on an Arduino, I've got this little this 16-channel servo controller, which is this thing here, you can just about see, and it's perfect for controlling a whole bunch of servos with just one. I think it's using I2C for the Arduino. So there's a library that you get, run it on the Arduino, and then you can individually address each one of the servos and control it separately for all sorts of things. So we're using it for our arm at the moment. I've just been following the hookup instructions and information on the Adafruit website to get an idea of how to do that. And what we have here is an Arduino Uno, a 5-volt voltage regulator, and the servo controller, and then the servo arm just here. At the moment, I'll talk about the powering in a second, because when I first set it up, I was having difficulties powering it. What I'm using now is a nice big Sony 7.2 volt battery that I'm going to use to run the whole robot, because it's a really nice battery. It's I think 42 watt hours or 47 watt hours, so it will run for at least a bit more than 2 hours, I've calculated, with the arm and the Raspberry Pi running the sort of brains of the robot, and the servo motors and Wi-Fi, and also the webcam. That should all run for about 2 hours on a single battery of this, but you can also daisy chain them, so I can run 2, so it should be able to make it run between 4 or 5 hours, and also allow you to hot swap from one of these nice battery packs, where you can unclip it and clip it back in and also see the status of the battery. So that would be quite good to have, so you don't have to turn it off. You can just like stick in a new battery while it's running without it turning off. So one thing to point out was when I first set up this circuit, I had, so we have the Arduino here, we have the voltage regulator and the servo controller. I have a Nano here just ready to swap out the Arduino for a Nano, but we're not using it at the moment. But what we had was, I was putting in either main supply 12 volts, so very high current, into the Arduino, which was going through. The internal voltage regulator was giving 5 volts for the chip itself and also for the servo controller chip. And then the V in, which was the either 12 volts for the mains power supply or 7.2 for these batteries, was going into the voltage regulator, getting reduced down to 5 volts and going to power the servos. What was happening there was, when the servos would use very high current, when it starts up and they all have to pull themselves into position, it would overburden the battery. It wasn't so much of a problem for the mains power supply, but it was still a problem. So it would use a high draw and it would freak out the Arduino, so it would reset and the whole thing would just be twitching around like crazy. So what we've got now is the V in, the 7.2 volts with the battery going straight into the voltage regulator. The Arduino doesn't have to have all of that current going through it. It's just taking a little bit of the V in to reduce down to 5 volts for its own internal circuit and for this chip. And we also have a 470 microfarad capacitor on the servo controller, which just smooths out the draw from the servo. So when they start pulling very high current, this acts as a little store of charge that smooths out the draw through the battery, so the battery doesn't have to provide very, very high surge current. And that means that it's running fine now from the battery. Rather than twitching away and resetting the Arduino, it's happy to run just on that little battery. So, alright, I'm trying to build now a nice control system in the Arduino platform, and then talk to it from the PC at the moment, just directly via serial, and later on we'll be doing that from the Raspberry Pi via serial into the Arduino, and then the Raspberry Pi will be getting its control signals via the internet. So what I've got on the Arduino is just a very basic sketch that uses the Adafruit servo controller library. I just set up all of the different servos, give them a name, and give them a particular control character so that we can talk to them individually. And also this is just servo settings for where they start off with, what position they start in when we reset the servo. So the sketch just turns on serial pretty fast. It's not a slow serial connection. Sets up the servo controller, resets the servos to their reset position, and then goes through in the loop to pass commands, and that's listening to serial port, and I'll show that in a second. So we have two other files in this. One of them is the actuators, which just has this servo reset function, which just goes through and sets all of the servos to their initial positions based on this. And another function which just is, it doesn't do very much at all, it just gives a nice name to the function to position a servo. So set servo. Then in the pass commands, this runs over and over again while the sketch is running on the Arduino. Just listens to serial input. This is code that I've written for another project, so I'm just using the code for serial communication to the Arduino. And a character starts off with a $, and then there's a letter to indicate the which servo you're trying to address, and then there's a number, so this is slightly different. There's an integer and then a full stop to indicate the end of the command. So this pass commands function just goes through, waits for a command, which is the $ symbol, and then goes through to the rest of the function, which checks to see whether you're addressing what the first character is, so whether you're addressing the claw or the hand or the wrist or the elbow, etc., just based on these single characters that are set up here. And then it takes an integer and basically sends that directly to the servos. So I have this. The Arduino is now listening to serial input. If I went into my serial monitor, let's just see this. Okay, so if I go into my serial monitor now that it's running, I can, let me disconnect and reconnect. Okay. Just make sure that the connection speed is correct. And I'll try that again. Okay, so I should be able to come and say $, let's say the wrist, and set it to 200. Is that working? We're having problems connecting to the port. Let's see what's going on there. Still having problems connecting the port, which is funny. I think it might be because I've written a new way of communicating with the servo. I'll just close this for a minute because I want to just show that the direct serial connection is working. Just restart this again. And let's have a look. Make sure that the port is set up. Yep. Go into the serial monitor. Okay, there we go. And so $, let's change the wrist position, or the claw position actually, that's kind of fun. And set it to 200. And you can see that that's, or I'm not sure if you can see that, but that's opened the claw now. Now we can send another command, which is the claw again, and we'll set it to, I think about 370 is the close position, and it's just closed there. So you can directly communicate with the Arduino just by manually entering commands into it, but that was just the initial way of testing the communication to the Arduino. And what I have now is let me just start it up now. I'm building a Unity app that not only allows you to communicate to the arm, but also has a little model of the arm. So what I have here, here's my little model of the arm. I'll start it, and should see if it's communicated. That could have worked. Let's find out. So I have this little hierarchy of different parts of the arm. I should be able to. There we go. So I'm just building a little physical model of them, where I can also come in and manipulate them as well. So all of the different sections of it I can control in real time, and the position in the model updates. I haven't finished building it yet. There's still a couple of sections which I haven't included, but I'm just in the process of building it. So you see the arm there. You see here that this part of the model is straight in this representation. That's because I haven't added this extra sections to the arm. So let's put the arm a little bit sideways so you can see it a little bit better. So I haven't finished building the model of the arm, and when I do that, the arm will be aligned correctly. Okay, so now that I have this model, and what's happening in here is that I've built this little model which is repositioning these physical elements in the Unity sketch, and also as part of this, it's pretty messy code, but as part of this code, I have a serial port controller in Unity, which is just this guy here. Very, very it doesn't have threading or anything, it's just very, very basic open port that when I put data into the serial buffer, it will send it out. So this is communicating to the Arduino, this object, and each one of these sections, each one of these scripts is going through, and when the position is updated, it will go through and update the serial with the correct command. So for each one of these objects, it has the command string for that particular part. We have different options for what type of connector it is, and we can select it, and it will manipulate the child objects of this section correctly. So for example, this hand is set up as a Z rotation servo with the claw pivot, which is just below it, as the child object. So what happens is the pivot point that we've set up there is the point at which it will, you can see the point at which it will rotate, and then when we move the displacement, that child object that we've set up will rotate according to the behavior of a Z rotation. and as this value updates, the servo pulse value will update, and it'll be sent to the Arduino, and then the Arduino will send it to the servo, so it updates pretty much immediately. We need to do a little bit of setup for this, so we'll say, okay, this is a servo, rotating servo, so we'll say what angle is the minimum angle that it will rotate to, what's the maximum angle that it will rotate to, and when you're setting it up, it takes a little bit of configuration to make sure that the minimum pulse and the maximum pulse is correct according to the servo. So you just have to measure the angle, the maximum angle, change the displacement, see where it sits. So for example, when we set it to 110, it's clamped to 110, we can see that the pulse is 620, so we go, okay, the maximum pulse is 620. We set the displacement all the way to the lowest, and we see that that's 110, the current pulse, so we set that to the minimum, and then it will automatically map that displacement between 110 degrees anti-clockwise and 110 degrees clockwise. It will map that to the correct pulse to the servo. So this is pretty cool to be able to see it update in real time, and to be able to, at the moment, changing it is a little bit annoying because we have to go to the different objects and change it. But the next thing that I'm going to do is plug in an Xbox controller and just set it up so that the Xbox controller, the different controls of the Xbox controller, will individually modify the displacement for all of these sections. So once I've finished building the model, I will, oops, that's no good. I think I was just, there we go. Once I've finished building this model of the arm, I will set up an Xbox controller with the input individually changing the settings for all of these different arms. And yeah, then I'll make another video to demonstrate that. Okay, thanks for watching, and if you have any questions or comments, just stick them under the video and I'll be happy to answer them. Cheers.